early 2000s, most of the big sports equipment manufacturers were sort of in a displacement race in the quad world. They were all making bigger and bigger quads, and Arctic Cat had come out with this 700cc 700 H1, and that was their kind of bigger bad boy to do all this. The one we have in the shop today is a gray one of this style, but they make about 45 horsepower, quite a bit lower than a lot of the other brands, but good torque. And that's the one there that we're going to work on today. The customer had called me and said that they had put in questionable fuel and ran it until it pretty much didn't run anymore. So we thought that we might have a bad fuel issue, but I usually start out most of these non-running units with a compression test. So I'll bust out my compression tester. My favorite one is the OTC brand. I've done the Snap-on, the Mac, the really cheap ones. The OTC is my favorite. I actually have called some pretty rough engine because of a bad compression tester back in the day when I used to work on cars all the time. So it's really important that you have a good, trusty compression tester that you trust. And then once in a while, question it and try it against another one that you might have. Always keep a nice fresh Schrader valve in the end of your compression tester. It is what retains the pressure and shows an accurate reading on your gauge. So yeah, I always put a fresh one in when I have a questionable reading. So this one got a fresh one. I'm going to throw that down into the spark plug hole. And you have to make sure that either your throttle valve itself is all the way open, or like in this case, I just have it off. And that way you get the maximum amount of air and you'll get the most accurate reading from your compression test. So to find out what you need for compression, you got to look up in the manual. Here's the one for this unit, and according to Arctic Cat, they want 130 to 155 on the 700cc quad. So that's what we're hoping for. On the gauge, that'll be somewhere around here. So then let's crank this thing over and see what we get. Oh, not good. Not good. That is nowhere near it. Yeah. So you can't really see it, but there was even blow by just from the compression test coming up through the valve cover. So it's going to have to get the old, tear down. So I had done some off-camera, diagnosing and inspections, and I couldn't see anything through the spark plug hole as to why this had happened. The cylinder looks good. The top of the piston looks good. I'm going to pop off the top of the rocker cover here and make sure nothing in there is obvious, but it ends up being that the customer agrees that we have to tear this thing down and figure out what the hell's going on. So it's going to be a bit of a long one, but this is the entire ride we're going to take to get this quad to running again. It's a really simple, common design, what makes up this engine. There's about 3 or 4 different companies that were using pretty much the identical engine. I think they'd all designed them together. The Yamaha Grizzly's got one, Suzuki something, because this engine's actually been designed by Suzuki. So you can tell when you turn them apart, they're all extremely similar. To get things going, you got to get that camshaft out so you can remove the head, and that requires you to take the chain off the cam. And that's what you got to do there is you got to relieve the one-time use cam lock, like the bolts have a little bit of a lock plate there, and I'll show you that later when reassembling. The cam chain tensioner has to be relieved so that you can easily pull off the camshaft pulley. And there's that lock plate again. There's two bolts that are secured by the same plate. You got to make sure you don't drop anything down that chain valley, because it goes down into the the crankcase, which you can't get to very easily without removing the entire drive belt system and then cracking the side of the case open. So avoid it if you can. There's a little keeper that can fall down into that area. So when you lift up that camshaft, make sure you take into account everything that's in that area. So again, don't drop anything down there. It's kind of important, especially if you're not sure if you're going to be pulling the entire engine apart, splitting it down to the cases. Thermostat housings, coolant hoses, they all have to come off, get drained, and then you can crack the head bolts loose. You don't want to just pound these off with an impact gun. You want to, crack them loose first in this manner. And then once they're all a little loose, then you can go ahead and pull them out with something electric or powered. And there, get your power tools out. They are long screws, or bolts. Get them out of the way and carry on. At this point, we still don't know why this engine has such low compression. The smoking gun hasn't appeared. So there's about 6 or 7 little bolts that kind of sub-hold the head down besides the 4 main bolts, and they're all sort of hidden underneath the flanges and such. So the last of the screws have been taken off, and my Matco tool guy was here, and he was curious and wanted to get his hands in there. So you'll see him poking some assistance in. It's always so exciting at this point when you get to see what's going on inside there, and hopefully you have that reason why the unit isn't working, or whatever it is you're taking apart at the moment you're going to finally see inside it. And we see nothing. There's still no reason why this thing has no compression. There's no damage to this. There's no indications that an item has failed. So yeah, got to get that head gasket off. Look at that. There was no milky oil or coolant, so we weren't worried about it actually being like a crack through the water jacket of the block or a bad head gasket. But I still don't plan on tearing down the case, so I got to keep that chain up and avoid it bunching up at the bottom and maybe causing some damage to one of the gears. But get that chain up, find a way of keeping it upright if you can, and then we got to rotate the crank down to see what the cylinder walls look like, and still nothing. There's absolutely no reason why this thing has no compression from what we can see, and it's a low hour unit. Like There's no reason why we would think that the piston rings have failed. It just doesn't make any sense. It's a very low mileage. It's not been abused. It just had a bad batch of fuel get pushed through it. So the step from cylinder head off to cylinder off is pretty quick. And we're just going to look right now. Hopefully we finally see what the heck is causing the problem. A couple of seconds to get the last coolant lines off. They're stuck on there pretty good. There's a few tricks to get them off. Sometimes you spray a little silicone on them, but some kind of a split prying device, the end of a wrench, or I actually have tools that do it, and you can get that off so that we can finally get this cylinder out of here. Oh, there it is. As soon as it came off, you could see it, like the piston's in pieces here. The ring lands are destroyed. The rings are actually shattered. Okay, so the verdict on the Arctic Cat is this. The really crappy fuel definitely caused a massive amount of detonation, and maybe someone inexperienced with how engine ping sounds, because it's not normal in power sports really, just let it rattle away and ran it a little hard afterwards. So the damage was definitely caused by that, and we have a shattered piston. However, I spent a bunch of time with a magnet, some grease, and a coat hanger and a bore scope, and I got all the chunks out of the crankcase. So I think we're going to get away with just installing a new piston, because somehow the cylinder didn't get any damage. Like, with the way that those oil control rings were not even sitting round anymore, this thing would have been going up and down fairly fast when it happened, even if it was at idle, and it didn't gouge the coating on the cylinder. So, like, it's mint. So we're going to replace the piston, all right, because all the piston pieces are all here and accounted for. Okay, I stuck them all together and I recreated both ring lands. I have patched together and made sure all of the ring pieces are together. And there just isn't any reason not to throw a new piston in and have a good day. Skirt that is right below this blown out ring land doesn't even have any like marks you can feel. Top of the piston is mint, and that's why when I looked down there with a bore scope, couldn't see any issues with the piston. It's crazy. So a few weeks down the road, parts started showing up, and we were ready to get back on fixing this quad. The piston was easiest coming right from Arctic Cat. It's sort of a unique one, being a single overhead cam 700cc. So just go with Arctic Cat. It came with rings. Everything was good to go. Same with gaskets. The gaskets on these things are kind of strange though, because the water sealing O-rings aren't part of the gasket. Jug again is in great shape. It's got one of these bevels in the bottom, which most motorsports do, so that the piston with rings can slide up from the bottom. Now, when it comes to installing pistons on engines sitting inside the unit like this, or on a bench, stuff the hell out of those holes. You do not need that the wrist pin circlip falling down there when it doesn't go into the piston the first time. Now, pistons have a orientation mark on them. Right here, it is this, and that faces towards the exhaust port or exhaust valves. I use this assembly lube a lot. It's gooey, it sticks to things, it seems to work. Pre-lube everything. I put a little bit of lube on anything that could possibly need it to start up. Once the vehicle's running, then the oiling system takes care of whatever it needs, but that first startup is when a lot of damage can happen. So, unlike normal, the circlip goes in on the first go here. So it didn't need those rags, but boy, if it ever falls down into that case, you've got to get that circlip out. Not just because you don't have another one, but because of the damage that can be caused by a hardened steel spring inside your crankcase. So this next series of videos, we've got me trying to put the piston into the cylinder. It is a real pain in the ass on this one. The skirt is so short and the piston to ring land is so tight that it was really difficult. Only made more difficult by the fact that I tried to slide the one timing chain guide in at the wrong opportunity. So you'll see I try and put the guide in here right away. And if I would have been following a repair manual like I should have, I wouldn't have done that. And I end up with a lot of extra work. So here you're going to find where I did the bad. I don't know why I didn't clue in that things weren't quite fitting right, but nope, just go ahead, get her done, put her together. Yeah, that's right, dummy. It didn't work the first time. Try it again. We'll chalk it up as a lesson because I promise you I'll never do it again. But you do end up messing around and getting everything fitting just to pull it all apart again. But eventually, we get the piston up there and it's okay. The guide is out of there. We're ready to get this cylinder down into its location. Through all the messing around, my timing chain tensioner had released itself back up into the tensioning spot, which I don't realize for a while, but I get the chain up and try and seat this here, and it works pretty good. It's very light tapping just to get it onto the dowels. So another thing that happens in these engines is the chain's not really held onto the bottom sprocket very well. So it slides off when you're, installing all the parts. So you got to get a long screwdriver down there and work it onto the crank pulley. And there you go. That's when the guide is supposed to go in. It slides down. Perfect. Now, like I said earlier, you got to make sure you replace these nitrile O-rings. This is what keeps the coolant from protruding out of the head gasket area because it's not built into the head gaskets. Most of the clamping force needed to keep the gaskets from leaking is done by the head bolts, but around the base and a few spots of the head itself, there's a ton of little M6s and some flange bolts that do the rest of the job of sealing the gaskets. So they're not always the easiest to get to, and that's what I'm doing right here is getting those, and then we're inserting the main head bolts. As you can see from the packaging, you never reuse head bolts. You just don't. Sometimes people will have studs. Studs are acceptable to be reused, but head bolts are torqued to yield. So that means they're actually stretched every time they're used. And that's again, following your procedures, it'll explain how to do that. I show the first two torque settings, and then my camera shut off for the final yielding of the bolts. Don't get all upset that that's an impact gun. It is a 1/4-inch impact gun. It is just to thread things in fast. I've even got it on the lowest setting, so there's no torquing on that. The first torque happens with the torque wrench. I start all my torques with a very light setting. So this is 15 foot-pounds, which is nothing. And that way I know that my bolts have at least started a even torquing. So 15 foot-pounds is where I start them. And then I go from there in the service manual, what it recommends. Yeah, there's no way I'd be able to do the yield with that little guy. It's maxed out probably about 50 foot-pounds. And yeah, you need a big ratchet to do what you need to do. So like I said, it was done between that stage and here. You can see I'm trying different shots to see what works best on videos. Those are kind of cool. My tripod has like a ratcheting thing that lifts the camera up. It worked out well. So clean all your surfaces, get ready for sealant. None of the old Yama Bond can be there, or you'll end up having too much of that stuff around or RTV, and it'll actually clog up the oil pump and pickup. So again, with the pre-lube, got to make sure nothing gets started up dry. I'm setting the crankshaft to top dead center in anticipation for the camshaft. Now the camshaft has a line on the cam lobes itself, on the shaft itself. So with the letters facing upright, there's a line, and it wants to be perpendicular with the edge of the basically cam cap. And then this dowel needs to be facing the exhaust side as well. That way you know you have it at the top dead center setting to go with the marking on the crankshaft itself. Like I mentioned before, this line has to line up with the top of the cylinder head here. And if everything is lined up correctly, this dowel will be in the front, this line will be perpendicular with the head, and the mark on the crankshaft will be at top dead center. This is the keyway that you have to have. If you don't have this when you're reassembling, it's dropped somewhere and likely down into the crankcase. When you install your Loctited camshaft sprocket bolts, you need a new lock plate. Do not reuse the lock plate. Tighten this up almost tight, but not fully tight, so that the holes will be easier to line up on the other side to get the other bolt in. There. Now you can tighten these up and it can be a little tighter all the way to spec if you wish at this point. Before I put my final torque on and bend the lock tab up, I want to confirm that the line still works and the dowel is still in the front. Then I'll finish up torquing those. This next product, it goes by many names, but I call it Yamabond. But Honda Bond, Kitty Bond, Gray Permatex, it's all the same shit. It is for sealing motorsports case halves or, on automotive applications, transmissions, anything that doesn't get a gasket and it's not anaerobic sealer. This is the stuff you use. It just works good. Next step is, of course, valve adjusting. You've got to make sure that everything is okay. This bike requires a spec of 0.05 to 0.10 millimeters, both intake and exhaust. So not super precision, but again, they're not a super high horsepower unit and more about reliability and torque. When this bike came in, it had a leaky oil filter gasket there, like not the actual oil filter, but the cooler itself. So we fixed that up, put a new one of those in so that when it leaves here, it shouldn't have any oil leaks. Another thing is that when people install these oil filters with the hex on the end, they use wrenches to install them. It's just for removing. Using a wrench to install them can actually crack the spot welds that have mounted that nut on there. And then that will allow oil to leak out of those cracks. So don't use the hex for tightening them. New exhaust bolts are important. Don't be cheap. You're putting all this work into it. Get new fasteners for anything that could break or are badly corroded. Next step is getting your throttle body on. This is completely the same as a carburetor install would be, because this engine actually usually had a carburetor, but in this one, that was an EFI. Just a few more connectors to put on, but same spot, same ordeal. Make sure everything's tight, clean, and yeah, you'll have a good running engine. When the thermostat housing goes on here, we're ready to start putting fluids into the unit. At our shop, we only use Motul. It's worked for us. It's really high-end oil, and it always beats or exceeds any specifications from any manufacturer. So yeah, it's expensive, but you get what you pay for when it comes to oil. I also installed a iridium spark plug for this guy. Might as well have it so he doesn't have to have any more services for quite a few years. And because it is a different plug than what it came with, same specs and everything, but I always like to make sure that we don't have a contact between the piston and the spark plug before I start it up for the first time. Yeah, that was successful. So I look over it, make sure there's no leaks, and carry on reassembling the rest of the quad. Now, some time has passed since I first pulled this quad apart, and I'm reassembling it. So putting all the fasteners back that should be there and often weren't there when I disassembled it, but I don't remember that. Anything that I did take off, I put in labeled Ziploc bags. It's always how I am because I have so many units tore apart at any given time in the shop. Just like the oil, the coolant we use is MoCool. So it's Motool's brand of coolant, motorsports coolant. That isn't a MoCool bottle. That is just a generic Piston bottle or whatever. But you can see when I spill a bunch of it, it's red, it's MoCool. So you got to fire up the unit and let it run and heat up to gurgle any of the air bubbles out. But yeah, here you'll see the mess I make. At least it's extremely cheap coolant to just be pouring on the floor. Man. So I let the bike go through several heat cycles. Fan kicks on, fan kicks off, so on and so on. Make sure that I'm not putting all the plastic panels on prematurely. And then while all the panels are off, I'll give it one more coat of brake clean just to make sure I've eliminated any old oil residues. That way when the unit's out driving around and comes back in for service, if there's any new oil leaks, I can tell that it wasn't from the previous repairs. Anything I can, I try to clean up before I put on. I don't like touching dirty stuff. It's weird. I know as a mechanic, but you can see I've got the white gloves on there. It's not my favorite thing. Dirt doesn't do it for me. So I try to clean things up. I use a lot of Dawn and soap to get all the plastics looking as good as they can when I go to reinstall them. These things will likely never get seen again by anyone other than a mechanic, but it should be clean. Yep, don't like it dirty. I go get the soap, gotta clean it. There we go. At some point in the quad's life, the customer felt that the battery dying all the time was because of a drain on the system, but not usually the case. With motorsports, it's almost always the batteries or someone's left the key on. So I put my Diagnostics multimeter on there and checked, and again, confirmed there's no reason for there to be a drain on the battery. It actually drew 0 amps, not like 0.00 something amps. There was 0 amps getting pulled when the key was off. So I removed all of the, it was large current cable through the glove box, and it was annoying. So we took it out, made sure that the unit was perfect and no strange key or, backup system was ever going to be needed to get this thing out on the trail. Because honestly, the way it was, it probably would have caused them issues somewhere that they didn't want it to happen out in the trail or field or something. So it's good now. Motorsports batteries are some of the worst. I think it's because they sit for so long, unused often, or people will put what's called a trickle charger on them, and that just pumps voltage to them all the time, and it just boils batteries. And motorsports batteries are not always made out of the best stuff because they're expensive. The good ones are expensive. A USA brand battery costs a lot of money, and the ones at Canadian Tire likely have been activated for a year before you buy it. So, you're getting kind of a garbage unit for cheap. And the cheap ones will have a high resistance and will actually self-discharge all the time. So get a good battery, get a good warranty, have a battery tender when you're not using it, and have less battery troubles. So if it was missing a plastic clip when it came in, it sure won't be when it leaves my shop. I have a massive assortment of different plastic clips, and I have a thing where everything kind of has to be fixed on the way out. Even cracked plastic, like I usually will throw a couple of quick welds in those as well. But I like units to be in good shape when they leave my shop, especially after spending money with me. So while I put the last few things into this quad, again, I really appreciate you guys watching these. I know they're long, they're not perfect. I'm getting to where I'm happier with some of the things that I do in my videos. But man, they sure do take a lot of effort. But in the end, it's really nice for me to be able to have a journal of all the repairs I've done, and it gives my customers an ability to see the work that was done to their quads, and other people that want to use me can see that I'm, I actually care about what I do, and they see the process of fixing whatever unit they've brought to me, be it a quad or a dirt bike or a street bike, which is, and that's what I like to do. So I have no grandeur visions of making money doing YouTube, but it's a really nice feature for the people that use my shop. So if you would, subscribe. Obviously, you don't have to watch these, but I appreciate it. And let me know if there's anything you'd like me to change or that you like or don't like, and we'll get her done. But have a good day. Thanks a lot.